Questions 62 and 64 ask us to determine whether each relation is a function, and then we'll have to understand why as well. And so, first of all, let's take a look at this one. Is this a function or not? Well, a relation, all it is a series of ordered pairs, and there's a bunch of different ways they can show it. They can show it as a list of ordered pairs like this, a mapping diagram. They can also have a graph, and a graph has so many ordered pairs that we can't even count them. That's why they're nice to draw. We could also have dots, and those represent points, just like we have here. And we also have the coordinate plane, which we'll see in the next problem. So let's take a look at this one. A function, well, what you're looking for are the domains. And so that's what we're supposed to find out first, though, is actually the next question asks about domain and range. The function is whether the domains end up repeating. So look at these domains. The domains are always the first number. They're your x value. So domains equal x's, and ranges, those are your y's. And so all we're concerned with when we're looking at a function or not is the domains repeating. So I don't see the domain repeating here, so this is a function. We'll say repeats or does not. I'll say domain. Domain does not repeat. And so since it doesn't repeat, that means that we have a function. This is a function. And taking a look at the next one, again, you're looking for those domains repeating. So the domains are the x values. Look at this one here, 4, 6, and 4, negative 6. See how the 4, we have two domains, but we get different range values. So these domains don't have the same range. So this is not a function. And the reason it's not a function is because the domain 4 has two ranges. So that's why we would say no, it's not. Look at this one. These are going to be your domains here. These are your ranges. And the first number where it starts is always our domain. Notice that the arrow starts here and goes to the 6. So the 6 is our range. These are the outputs. Domains are the inputs. Notice this domain right here. It has two different range values, so it's not a function. And the reason it's not a function is that the domain 1 has two ranges. Well, look at the next one, a vertical line. Vertical lines are not functions because these are all domain values. And each of those domain values has a different range value because you're going up and down that line. So not a function. We'll say the one domain, because a vertical line only has one domain, the one domain repeats and has multiple ranges. This one is a function. You can use that vertical line test. Use vertical. It's got to be a vertical line test to determine whether it's a function or not. You see, if you pass a vertical line through, it only crosses at one spot. No matter where you cross it, it only has the one range value. So we'd say a function, and you can use, we'll just say passes, not just the line test, but the vertical line test. Because it's not a horizontal line, it's not a slanted line, it's a vertical line. Notice this one here also passes. See, I could pass a lot of vertical lines through, but they only cross one time. So this is a function. And it's a function because it passes the vertical line test. This next one, notice that when I pass the line through, it fails because this one domain has two different ranges. So we'll say not a function. The reason it's not a function is that multiple domains have two ranges, but we'll just say fails the vertical line test. Well, the next one has just a series of points. So notice if any line up vertically. Notice these line up vertically. So this, again, is not a function. The reason it's not a function is that it fails the vertical line test. So vertical line test says you can only have one range for each domain. So each domain can only have one range. Here we're supposed to find the range and the domain. So the domain represents the x values again. So read off all the x values. So this is -2, and this is -1, and this one is +1. This one is +2. And this last one is over 1, 2, 3, 4 spaces, so +4. So you're just reading off those x values for the domain. The ranges, you read off the y values. And so you just start at the bottom one here and down 2 spaces, so -2. This one's up 1. This one is up 2. And this one's up 3. And the last one's up 1, 2, 3, 4, 5 spaces up to get to that other one. Just reading off those x and y's. Well, that's question 63. Then we've got a few more rate problems to just practice, since those are difficult problems. Taking a look at this next one here. A pipe fills a tank in 50 minutes. Pipe B fills the same tank in 40 minutes. So you're trying to find the rates. Well, the rates are always the reciprocal of the times. So here the rate is 1/50th. So after 25 minutes, this job is done. Pipe A has done half the job at least. After 50 minutes, done the full job. Pipe B, 20 minutes done half the job. 40 minutes the full job. So how long will it take the two pipes if they want to do a job that's 3 times as large? Oh, we got to be careful here. 3 times as large. Okay, so the job completion is 1. The rate is 1/50th, and we're going to add on that 1/40th, and then we're going to add those two numbers together, and then we've got T. But at the end, since the job is 3 times as large, let's multiply by 3. So let's come up with that common denominator first. I see 10 goes into these numbers. So we'll go ahead and take out that 10, and then we'll just multiply by the number it needs. So this 4 needs a 5. The 50 needs a 4. So go ahead and do some work there. We got 4 over 200 plus 5 over 200. And then we'll go ahead and multiply by T, find out what that T is. But once we do that, once we get that answer there, we're going to take that answer and we're going to multiply it by 3. So once we find out what this T value is. So we go ahead and do that work. We got 9 200ths times by T. And really I need to put this 3 on the other side. So let me fix that right now. So when I'm multiplying the answer by 3. So let's go ahead and do that. So this is the number that I'm going to multiply by 3. So then we'll say equals 1 times by 3. And so when I go ahead and do this work, I'm going to end up multiplying by this 3. And I'll do it this way. So I'm going to multiply by 200 ninths to cancel out that denominator. Do the same thing on this side. And look for that common factor. So again, this is the time at which they can do the job together. The two pipes do the job together in 200 ninths. But I'm going to multiply this by 3, so I'm going to end up doing some cross-canceling, make the problem a little bit easier. Now I just have to do 3 into 200. And so I do that work. Looks like it goes 6 times. Makes 18. Got another 2, so 66 repeated. So 66 and 2/3 minutes is how long it will take the job if it's 3 times the size. Well, it says Ed's average driving speed is 80 miles an hour for a 5-hour trip. Well, one of these problems again. Distance equals rate times by time. So 80 miles an hour for a 5-hour trip. So this is going to give us a total distance. 400 miles. That's the total distance here. And we have during the first 4 hours, he drives at 60 miles an hour. So we go ahead and multiply those. That only makes 240. Well, what is the average speed for that last remaining hour? Well, we don't know what that is, but we can find out the distance by doing some subtraction. So we do that work and we end up with 160. So while he's flying, because when we divide by 1, we get that same number. So he's going at 160 miles an hour through Nevada, I guess. So there it is. That's how fast you have to go in order to average 80 miles an hour for that 5-hour trip. The last problem here talks about 2 cars leave the same town or leave town at the same time going in opposite directions. So that looks like this. So one's going this way, one's going this way. One's going 35, one's going 40. So we'll call the one going faster D. The one going slower, notice that the total distance, this is a total, they are 200 miles apart eventually. It's got to go 200 minus d. So you go ahead and do some work there. You're going to set up your two problems. Distance equals rate times by time. So our distance is going to be 1 is d. And we said that one going faster this time. So 40 miles an hour times by t. And then it equals 200 minus d. And then this part is 35t. And so what we're going to end up doing is using the substitution method. So take that 40t, put it in place of that d down below. So now we got 200 minus 40t equals 35t. So we're just going to do an opposite operation, move that 40 back to the other side. Now I have 200 equals 75t. Notice I'm adding those two numbers because I'm doing an opposite operation. I have to add 40 to both sides. And so when I do that, I end up with 75, and I have to do some division. Well, it's not going to go in there evenly, but we'll just write it as a mixed number. So divide by 75, and you get 2 2/3 is our answer. So 2 2/3 hours is the time it takes them to be 200 miles apart. Well, those are problems that you'll see on this quarter's benchmark. Good luck.